All right, so again, we're going to use the properties of logs and exponents to try to solve this. So I think the first thing that I'm going to do, and there's no right or wrong way actually, is I'm going to divide. Actually, I can't do that. Let me back up. This is I don't see parentheses, so I'm assuming that this is 4 times the natural log of x minus 8. I'm assuming that. So that means I'm just going to add 8 to both sides. I could be wrong. I won't know until I know. So that gives me 4 times the natural log of x is equal to 20. Now, if I want, I could divide by 4, and I get the natural log of x is equal to 5. So the interesting thing about this, remember that the natural log of x is the same as log base e of x. Also remember that when we have the natural log, I'm going to rewrite this. So it's like saying the log base e of x equals y. Well, remember, that's the same as e to the y equals x. Okay? In other words, this should be the same as e to the 5 is equal to x. So e is a number. I don't think this is right, though. I'm pretty sure this is the wrong answer. So let me double check here, because I think it might be x minus 8 or something like that. So let's see. E, this one right here, raised to the 5. Oh no, that was right. Well, yeah, it's close to 3. Yeah, 2.72. Huh, cool. So this is the right answer. Let me take a screenshot of it and we'll write it down. So x is approximately 148.4. Now I put the squiggly equal sign because that means approximate. Why? Because I rounded it off. This is actually the answer. It goes way further than that. And so when I round it, I should always use the squiggly equal sign. That means approximate. And that lets a mathematician that reads this answer go, know that that's not the exact value. Equal sign is the exact value. Approximation means that the answer's been rounded. Okay. That's it on that one.